Hi everybody, this is Mr. Folly, and welcome to Podcast 2.2. We're going to talk about the periodic table. You've been dying to learn all about it. We're going to learn the definition of periodicity. We're going to learn about two dudes, Mendeleev and Moseley, and how they figured it out. We're going to figure out the trend for atomic size and why. We're going to identify metals, nonmetals, identify lanthanide, actinide, transition metals, and man-made and radioactive. And that is it. So let's hop to it. It's the 16th of the month, so guess what? Teen Vogue magazine is coming. Woo! It's the 16th of March. Teen Vogue. Woo! 16th of February. Woo! Teen Vogue. 16th of April. Woo! And every month on the 16th, you get your periodical called Teen Vogue. And let me tell you, Jason just couldn't be more happy than when Teen Vogue shows up. So is Maggie. But what happens is repeating. The word periodic means repeating. So that means it repeats the 16th of every month. So that's why there's a periodical section in the library. Oh, don't jump too. Periodic means repeating. Periodic means repeating. Periodic law says when atoms are arranged by atomic number, trends will repeat. Atomic number, recall, is this. Okay. Now, there are trends in size. Okay. So the trends in size are you have huge, tiny, huge, goes down to tiny, huge, and it goes down to tiny, and as the Trumpster says, huge, and it goes down to tiny. Okay, so what's the trend that repeats? Well, as you start here, it's big, and then over here, itty bitty, bigger, itty bitty, bigger, itty bitty. So hopefully you can see that trend. Okay, did you write down that trend? I hope you did, either in words or pictures. Now you should sketch another periodic table and talk about charge. So here's the trend in charge. Whoops. This column is +1. So hydrogen is well, let's do lithium. Okay, +1, +2, +3, 0, -3, -2, -1, 0. Repeat. +1, +2, +3, 0, -3, -2, -1, 0. Hey, there's a pattern. +1, +2, skip, 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 +3, 0, -3, -2, -1, 0. So I can label this as +1, +2, +3, 0, -3, -2, -1, 0. And that's the charge trend. See how it repeats? Oh, so it does the same? Yeah. Oh, yeah. Okay. Dmitry Mendeleev saw trends when arranged by atomic mass. Oops, but close. He predicted elements and their properties before they were discovered. Wow, that is impressive. Woohoo! That's why he is a genius. Moseley adjusted the periodic table to be arranged by atomic number, which is a little bit better. Well, atomic size is periodic. We know as you go to the right, it gets smaller. As you go down, it gets bigger. Okay? This is the why. You must know why. Okay. As you go down the periodic table, so here's my cheeseball periodic table. As you go down the periodic table, there are more energy levels. We like to think of them as rings. This is how rings kind of exist still. Now, I prefer shells. So if you keep putting a shell on the outside and on the outside and the outside, the atom gets much, much bigger. So if I'm right here, and then I put a shell around it, and then another shell around it, and then another shell around it, it gets a lot bigger. As you go across, there are more protons for the same energy level, so the pool makes the atom scrunch in closer. So that means the biggest element, notice how this would be big, these are small because so many protons, because protons pull you in. Okay? Does that make sense, I hope? Okay. So let's say if you love your mama, you stay closer. Okay, so what that means is if your mama is right here, and let's say you're somebody that loves your mama so much that, I don't know who loves their mama. Everybody loves their mama. So if I'm person over here, if you love your mama, you're going to stay close. If you don't love your mama, you're going to go wandering off into the park and get hit by a car. Okay. So if you love your mom, you stay closer. Now, what causes this love? Protons and electrons. So more protons means you have more love. And this explains the lefty-righty trend. Okay? If you're the 25th kid in the class of 24, you are way far away in the hallway. So I'm going to boot you out into the hallway. Get out, Tahir. You're gone. Oops, don't jump 2 pages. How do we measure the size of an atom? We can't go from the nucleus to the outer electron. So you know how we've got a little nucleus. You need to go, oh, here's an electron. Let's just measure it. Because the electrons are in clouds and we can't pinpoint their location. So in other words, these electrons are impossible to locate at a certain time. So what we do is we find another nucleus, because we can detect those, and we take the distance between these two and divide it by 2. So it's an indirect measurement. Regions of the periodic table. You should know this. You're going to have to draw this and know it. Your metals are all of these guys. I should have a darker pen. These are metals. Whee! These are all metals. Whee! Okay. Non-metals. Ooh, can I be so bold as to change the color? Oh, come on. I can get a different color. There we go. Non-metals are here. And oh, you know what? Non-metals are here. Hope you colored a periodic table. Hope you labeled these on your periodic table. And then we have metalloids, which have properties of both. Ooh, do I have another color? Let's go red. Boy, that's not red. I'm colorblind. I know that's not red. And now I know why the color blindness gets me, because I can't tell it from the green now. Whee! Those red ones are the metalloids. Okay? So you have to be able to find those spots. So let's go over what those properties are. Metallic properties. Yeah, dude. They are shiny. They are malleable. They conduct heat and electricity. They have electrons flow. Okay. Non-metals are dull, brittle, poor conductors, and electrons are locked in bonds. So the difference between malleable and brittle, if I have something, say grandma's hip, and I hit it with a hammer, come on, art class, don't fail me now. If it's brittle, it will shatter. Oh, grandma's hip, and she falls down, and she'll never get up again. But if it's malleable, it will just dent. Okay? So, did I forget any? Shiny. Oh, I forgot lustrous. Lustrous means shiny. Okay? Ding, ding, ding. Region of the periodic table. You have the lanthanide, actinide, transition, intertransition metals. Okay. So, everything here is the lanthanide. Every down here is the actinide. I misspelled it. Okay. Then we have the transition metals. These are my transition metals. And then these guys together are the inner. Now make sure you call them inner, not inter. Inner transition metals. Hey, another region of the periodic table. Ohana means family. Lilo and Stitch say family means nobody is left behind or forgotten. Chemists say families are columns and have similar properties. They're in the names of the families of the A elements. Alkali metals, ba-bam. Alkaline earth metals, ba-bam. Oh, and you thought you'd get over it. Halogens, ba-bam. Nobly gases, ba-bam. Okay, and then these guys are called the boron group, the carbon group, the nitrogen group, and the oxygen group. So, but you need to know those other names. Those are the tricky ones. Electron configurations are periodic. So everything here ends in S1. Whee! So everything here is S2. Whee! Everything here is P1. Whee! And you get the idea all the way down to P6. Whee! And this would be D1. Whee! wee. I don't know why I'm saying wee, wee, wee all the way home. Okay. So if I said, well, what's the ending electron configuration of argon here? Well, I know it's going to end in p6, and it's 1, 2, 3. Argon would end in 3p6. So, oops, calcium ends in S2 because of where it is, and that's 1, 2, 3, 4. It's on the 4th energy level. It ends in 4s2. That is it. So there's a lot of writing, but I got through it. Families equal groups equal columns equal up and down. Periods are rows. Oh, I didn't say that. I bet that's on the podcast. You better believe it. Pod quiz. Yes, you need to memorize the groupings. Periodic means repeating. Periodic means repeating. Periodic means repeating. What is the periodic raw? Oh, my love runs cold. My energy has just been sold. Do 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 do.